All right. So how would we define, talking about system of linear equations, now we're talking about system of linear inequalities. How would that definition change that Bailey was telling us earlier? Instead of equations, we might use
graphs.
What's this word right here? Inequalities. So we're going to define a system of linear inequalities as, what just happened here? Hold on, let me make sure I'm precise. So we're going to say a set, a set of two or more, because we can have more than two, right? Two or more inequalities. Okay. So that might look something like this. 3x plus 5y is less than or equal to 30. And then our second one might be y is greater than 2x minus 1. All right, so do you guys see like the similarities of inequalities versus equations? Really the only difference is that we're working in inequalities now instead of equations with an equal sign, okay? So now we're going to move on to solution of linear inequalities. So a solution is an ordered pair. And what's an ordered pair again?
Like -2, 2.
Yeah, so it might look like this, general. Like that? Okay. So an ordered pair that is a solution of each. I'm going to run into my box. Ooh, stayed in. Inequality in the system. All right. Okay, so like on a graph, this is going to look a little different than we were talking about systems of linear equations. So I'm going to draw my graph. Okay, and I'm going to draw a line here. And real quick, so if this green line that I have drawn is an inequality, what do I have to do to it to make it, to like let us know that it's an inequality and not just an equation? Starts with an S. Shade. So let's say I would shade like above or to the right of this line. So instead of shading real quick, I'm just going to draw an arrow. Okay, hold on. Indicating where I'm going to shade, okay? So now I'm going to draw my other one. We're going to go this way with it. Okay? And I'm going to say that I'm going to shade this side of it. So, oops. So I'm shading below and to the right now. So can you guys guess where my solution would be? Because we're looking at where all of our solutions are for both inequalities. So it might be where our overlap is. So where's our overlap in with these inequalities? Yeah, so we want where they meet, yeah. But we also want like all, because remember how there's shaded regions in inequalities? We want where those shaded regions meet, which is going to be some overlap. So I'm going to say that this is region 1, 2, 3, and 4. Where's my overlap? Which region? Okay, so I hear 2, I hear 1. What's that side of the room thinking? You think it's 1?
It's 2.
Okay, so why 2?
Both
Yes, because both inequalities would be shaded in that area. So I'm only going to shade where there would be overlap. Okay? Because if I were to shade like in region 3, there's no solutions from this line that's in region 3 here. So that's why I left that out. Same goes for the other 2. I mean, yeah. So all 3 of these don't have solutions for both inequalities. Okay? How are we feeling on vocab? Does that make sense? Does the shading and how we need overlap for our shading, does that make sense? Yes? No? Seeing blank stares. Did you say something, Bryn?
Kind of.
So it kind of makes sense? Or you kind of said something?
It kind of makes sense.
Okay, so should we do some examples to see if it does make sense? Yeah. All right. Okay, so right now we're going to tell if each ordered pair is a solution of the system of linear inequalities. So these 2 solutions, like points, they are 2 separate problems. So we're going to focus on one and then get completely done with it, and then we're going to go to the other one and then get completely done with it. So I'm going to divide my workspace, and we're going to say that this section is going to be -2. And real quick, guys, I'm going to change this 1 in our first point to -1. Are we okay with that? So it's instead of -2, 1, it's going to be -2, -1. All right. So if I have a point and I want to figure out if it's a solution for an inequality, what should I do? We could graph it, but what could we do? But we don't have a graph right now. I'm not going to get into Desmos at all today.
Oh, like the equation we did the other day where it's like -2 times y.
-2 times y.
Like you put like the numbers in.
Oh, okay, so we plug in. Okay, I like that. All right, so how would I plug in -2, -1 into my top equation? Y is greater than 3 times x. How would I do that?
So it would be -1 is less than or equal to -2x minus 2.
Here, 2x, or is -2 our x?
-2 is our x.
Okay, so would we have an x in that? No, so then it would be -2 times 3. So then we would have -1 is greater than what?
Where are you getting the 3 from? Oh, up top. Okay.
Yeah. All right, so then what's -2 times 3? -6. All right, is -1 greater than -6? Yeah. So this is good. But are we done here? Can we say that it's a solution to the system? Or what else do we have to do? We have to do the other equation. So what would that look like? Who wants to help me out? Come on, guys.
0 is greater than 3 times 4.
Okay, hold on. So we're still working with this point here, this -2, -1. So how would we plug that into our inequality y is less than or equal to -x, -2?
1
Okay.
is less than or equal to -2 minus 2.
All right. And you said 1, but because the print says 1, but we're changing it to -1. Just a reminder there. No biggie. So what do we get here?
1 is less than or equal to, would it be positive? Yeah, positive 2
+2.
minus 2.
So 0. Because then, so if we have a negative minus, or, oh, it's a negative times a negative, that's a positive. Okay, so that's how we got the +2 minus 2. And then this simplifies to -1 is less than or equal to 0. Okay, how do we feel about that inequality? Is that true? Yes. All right. So then what does that say about -2, -1? Is that a solution for our system? Yeah. So we could write -2, -1 is a solution for the system. Okay. So how are we feeling about that one? Okay, we'll move on to 0, 4, and we'll really make sure that you guys got it. Okay. So someone on this side of the room, help me out here, okay? So let's do the first one. So y is greater than 3x. What's my y? 4. Okay. And then greater than what? 3 times 0. Thank you, Haley. And then so what does that equal? I mean, yeah, what does that simplify down to? 4 is greater than 0. Is that a true statement? Oh, yeah. So we know that 0, 4 is a solution for the top one at least. Y is greater than 3x. But let's check the bottom one now, okay? So what's our y? What's this inequality going to look like when we plug in 0, 4? You know?
0 is less than or
0.
is less than or equal to.
Well, is that a y up in the front of our equation? Inequality?
It would be 4.
4.
Less than or equal to 0 minus 2.
0 minus 2. Okay.
It should be 4 is less than or equal to -2.
Okay, and is that a true statement? Is 4 less than or equal to -2? No. Okay. So that's not true. So what does that mean for our point 0, 4? It's not a solution for the entire system, right? Okay, so I'm going to write is not a solution. Okay, guys, how are we feeling about that? Does that make sense? That's sort of what we were doing in 5.5. No, in 5.6. But now we're doing it twice and making sure that it works for both. Okay, so now we're going to graph. What kind of form is our first inequality in y is greater than or equal to -1? What kind of form is that? Not quite. Not quite. We talked about 4 different forms in 5.6.
System of or inequality.
Well, I mean, that's what this is right here.
Okay, I see that.
Okay, so we talked about 2 different types of lines. Okay? We talked about what kind of line goes, I almost said east to west. Horizontal. Thank you. And and then we talked about vertical form, right? So what form is y is greater than or equal to -1? Horizontal. Yes. Oh, I'm going to try to think about it. Okay. So I'm going to write horizontal form. Okay. Can someone help me graph this? What do I do? Thank you. This is not liking me today. Okay. And then is it a solid line or is it a dotted line? Solid. How do you know it's solid line, Raphael? Yeah, so this isn't just greater than, it's also greater than or equal to, right? Right. Okay. So there's my line that sort of goes through my point. All right, are we done graphing this one? Are we done graphing? No. What do we got to do? Starts with an S. Shade. All right. Which way are we shading? Are we shading above the line or below the line? Okay, I heard both. Below. Okay, should we try it out? Should we test a point? Okay, so is 0, so if you want to use point 0, 0, is 0 greater than or equal to negative 1? Yes, 0 is greater than or equal to negative 1. So we're going to shade above this line. Okay, again, I'm going to use arrows because I don't want to shade completely, otherwise I'm going to be erasing. Because we might not use this whole section. All right, so let's move on to the next one. What form is this in? Slope-intercept form. And how'd you know that?
Because it has the slope and then it has the y-intercept after.
Yeah. Another easy check is to see if y is all by itself, right? And then but y is all by itself in the top one, but the difference there is that there's not an x to go with it. Does that make sense? Okay. So someone help me graph this one. What's my y-intercept? 2. I heard it. And what's my slope? Is it negative x or is it negative? Negative 1. Okay. So I'm going to go down 1 and to the right 1. We're going to do that a couple times. Then I'm going to get my nifty ruler out. All right. Tell me about this line. Is it shaded? Is it solid or is it dashed or dotted? Dashed, and why is it dashed? Yeah, because it's just less than, right? Okay, which way are we shading? Oh, never mind. Hold on. I asked and then I didn't change it. Oopsies. Okay. Which way am I shading? What do you guys think? What point do you guys want to test with? 0, 0. Okay, so what do we get? So if we have 0 is less than 0 plus 2, we get 0 is less than 2. Is that correct? Yes, that's correct. So we're going to shade the part that has 0, 0 as a solution. Okay, so what part of the entire graph am I shading? Here, let me number it again. Sorry. Okay, what am I shading? 1, right? Because we got here. Do you want me to? Because I think I heard some confusion there. So instead of arrows, I'm going to use different highlight colors. Okay. Okay. Okay, so for my dashed line, we're going to shade it with green, and I'm going to shade everything below it because that's what we decided needed to be shaded. Okay, but with my solid line, I'm going to shade it with pink. We decided that everything above it needed to be shaded. Okay, so can you guys see it better this time? So what side has green and pink? 1. And that's why we shade 1. So then I don't need, it's getting a little chaotic, but that's okay. All right, does that make a little bit more sense on the shading? All right, how do we feel? Besides tired, I guess. You guys picking up on this? Or not at all? Again, you can tell me not at all. All right? Okay, what form of a line is our top inequality? What is that? What form? There you go. It's standard form. Okay, and one thing to remember about standard form is when we graph this, guys, well, I don't know why my R and M is so far apart, but whatever. We graph it by intercepts. So with y-intercepts, it's C divided by B, okay? And with x-intercepts, it's A. Ooh, nope. It's C divided by A, okay? C is my 2 in this case. What's my B in this case, guys? Ooh, I heard it over here. -1. Because if I don't have a coefficient out in front of a variable, I can assume that it's always 1, right? And since we have a subtraction sign in front of it, it's a -1. Nice job, Will. And then my A is going to be 1. Okay? So what's my y-intercepts here? We're doing C divided by B. So we're going to have 2 divided by 1, which is what? I mean, -1, which is what? -2, right? Yeah, no big deal. All right. And then my x-intercept is going to be 2 divided by what? +1, which is 2. Okay, so let's graph this thing. I'm going to go find -2 on my y-axis and 2 on my x-axis. Again, get my nifty ruler out. Okay, someone, while I'm drawing this, tell me about the line, the type of line. Is it going to be solid or dotted? Dotted, because we don't have that equal to sign, right? Whoop. Okay. All right, let's do the same thing for the second inequality. Or do you guys want to figure out where we're shading first, I guess? That might be easier. For the top inequality, where are we shading? To the top, you think? Anyone agree?
I concur.
You concur? Okay. So we're shading this way. Yeah?
Yeah.
Okay. All right, let's do the second one now. Okay, so what's going to be my y? I almost did a different type of y, and I know you guys don't like that. So y-intercept, what's my y-intercept going to be? What's my c? What was that? I heard a lot. -3. Divided by, what's my b? -1, which equals what? +3. Okay, my x-intercept is going to be what divided by what? Divided by 1, you said? Okay. Which is -3. All right. Let me graph this. All right, someone tell me about my line. Is it going to stay solid, or is it going to, or am I going to dot it? Solid. Okay. Which way are we shading? Oh, wait. Hold on. I forgot what example we were on. Can we talk about the shading? We'll talk about the shading, then we'll go back to the shading of the top one, okay? Is that all right? So let's talk about the shading right now. Which way are we shading? What was that? Okay, wait. Okay, so you're saying you're good? You're good? Okay. All right, so which way are we shading on our bottom inequality? Above? Okay, who agrees with that? Huh? Do you think it's above or not? Should we plug 0, 0 in? Okay. 0 minus 0 is 0. Is 0 less than or equal to negative 3? No, it's not. So that means it's not in our thing, in our solution set. So it's going to be above. All right, guys, I made an oopsies. I don't think it's supposed to be above our dotted line. Let's look again. Let's plug 0, 0 in. 0 minus 0 is not greater than 2, right? No. That's on me. So it's below. Okay? So where's our solution set here? Are we ever going to have overlap? No. So is there a solution here? No. So let's write no solution. Okay. What if, and again, okay, you guys don't have to write this down, but what if instead of this, our solid line being shaded up and above the solid line, what if we were shading below? Where would our solution set be then? Are we going to end up having overlap at some point in time? Yeah, and where? The dotted line. Can you come up here and show me where it would be with your hands? Maybe standing up might help you guys.
Right here.
Right there. So yeah, you'd say everything below the dotted line?
Yeah.
Yeah. Do you guys agree with that? Yeah. Okay. What if, so we keep our arrows here. We keep the shaded below the solid line. What if, instead of shading below the dotted line, we shade above the dotted line? Where's our overlap then? When's our overlap then? The middle section? I won't make you come back up, Brandon. But yeah, so it's going to be this section right here. It's not going to be above our solid line. It's not going to be below our dotted. Okay. All right. Do you guys want to write some inequalities? Write some systems? Yeah, you guys don't want to do anything today, okay? It's like pulling teeth with you guys today. All right, but I'm going to make you guys do it anyways. Sorry. All right, so we're going to write a system of linear